Where does alcohol come from? Is it drilled from a well? Are there alcohol lakes? What about oil? How do we use oil? How can we get gasoline from a black, thick liquid when gasoline is light and clear? These products aren't actually found naturally. They're found as a mixture, and they need to be separated before they can be used. This process of separation is called distillation. Last semester, I took a class that sole focus was on distillation, and I recently finished a 42-page report on distillation columns in chemical engineering lab. I plan on using distillation in my career in the future. Today we're going to go over what distillation is, how distillation works, and why distillation is important in our society. First, let's separate the facts from the fiction of distillation. Distillation is a process of separating two or more components. These components are chemical compounds that can be separated using heat. Common compounds that are separated are ethanol, which is found in water, ethanol, which is used for alcohol, and water, which is usually found with ethanol. Usually, distillation separates a mixture of equal molar components, meaning there are the same amount of moles of one component as the other. Let's say we have a 50% mixture of ethanol combined with a 50% mixture of water. We'll take this mixture and we're going to place it in a large column called a distillation column. In this column, the mixture is heated up and part of it is turned into vapor. The vapor will rise up the column and exit out the top. Since ethanol has a lower boiling point than water, there will be more ethanol that is vaporized. That means that at the top of the column we will have more ethanol, and at the bottom of the column we will have more water. Neither of these concentrations at the top or bottom of the column will be 100% pure, but a good distillation column will give you about 99% purity of pure separation. Distillation can separate, but there are some conditions. It requires a liquid or vapor feed, meaning there can be no solids. Usually there's going to be a liquid feed. And even though the vapor will exit the top as vapor, it's going to be condensed after it leaves the column and given to the product as liquid. There are two types of distillation. You have continuous distillation and batch distillation. Continuous distillation is where there is a constant feed going into the column, meaning there's also going to be a constant product being delivered from the top of the column and the bottom of the column. In batch distillation, there is a finite amount of feed that's put into the column, and the column will run until that feed runs out. Now that we separated the facts of distillation, let's vaporize the theory of distillation. Distillation is based off of the setup of the column and thermodynamic properties. In a column, you'll find several trays which separate the column into stages. These trays are metal sheets with holes in them, similar to this cheese grater. The trays will vary in hole size and orientation to allow changes in the vapor flow rate. Only part of the tray is covered with this tray. Only part of the column is covered with the tray, and which will allow liquid to flow over the tray and down in a hole specified for the liquid. This is the setup of the distillation column in the Othmer Hall lab. As you can see, there are several trays. Liquid feed will go into tray 7, where the liquid will fall down the column. And according to the third edition of Separation Process Engineering by Philip C. Rancat, each tray has a different component. The higher up you are in the column, the higher the concentration of ethanol in our example. So liquid will flow down the column into the reboiler, where part of it will be vaporized and sent up the column and through the holes in the trays. At optimal conditions, the vapor flow will be high enough for the liquid to be held on the trays without falling through the holes. The vapor will rise up and go out the top of the column and down into a condenser where it is turned into liquid. This is called distillate. The distillate will either be taken to the distillate tank as products, or it will be returned as reflux to the top of the column. At the bottom of the column, if the liquid that is not vaporized and sent back into the column is sent into the bottoms tank as the bottoms product. And like in our example, at the top of the column you'll have a 99% of ethanol, and at the bottom there will be 99% of water. The reason that distillation can work is because of the setup of the column and because of vapor-liquid equilibrium. Vapor-liquid equilibrium says if we have a mixture of two or more components and we know the concentration of either the liquid or the vapor composition, then we will be able to figure out the composition of the other phase using temperature and pressure. All stages will vary within each tray with concentration, but all those concentrations can be calculated with vapor-liquid equilibrium, and this is the driving force of distillation. Now that we vaporized the theory of distillation, let's condense the importance distillation has in our society. Distillation is very important for our day-to-day activities. First, without distillation, our energy production would plummet. Oil is found in its crude form, and it can't be used directly. It has a lot of hydrocarbons, which are good, but cannot be burned when combined. They must be distilled. And through this distillation, the crude oil can be turned into several products, such as gasoline, jet fuel, and natural gas. Natural gas accounts for 27% of energy production, according to the U.S. Energy Information Administration website. If we did not have distillation, this lack of energy production would cause us to rely heavily on coal, causing electricity bills to rise and a shortage in natural resources soon after. Second, ethanol would not be available if we did not have distillation. Ethanol is fermented from grains, usually corn. Corn is mashed and then grinded into a wet paste where it is then all solids are removed and then the liquid remains as ethanol and water. And this mixture is pretty much useless for consumers and for fuel. So the water has to be distilled out. Once it's distilled, we can use it in gasoline, which makes our gasoline more efficient and cleaner. And if we did not have this process, not only would we not be able to put it in our gasoline, but a 21-year-old like myself would not be able to purchase one. Today, we distilled the facts of the distillation process. First, we separated the information on distillation. Then, we vaporized the theories of distillation. And finally, we condensed the importance it had on society. You now know that ethanol does not come from a well, but it's actually fermented and then distilled. We also know that oil can be separated for a variety of products, like gasoline in our cars and natural gas used to heat our homes. Distillation cannot be performed by everyone, but everyone relies on the performance of distillation.